Okay, so I'm going to try to explain my solutions for last Tuesday's mock exam. Even though my solutions have been posted for a while, I haven't talked through them yet. Okay, so I've cut out just the important parts of the questions here. So we have the function g here is an integral defined function. They want you to find, where's my question? I hid the question. Oh, the question is to find g prime and g double prime in terms of f and f prime. There it is. I knew it was in here. So, So this is your part of the fundamental theorem of calculus, where to differentiate an integral defined function, it really is pretty straightforward. It's just a matter of you forgetting it or not finding it in your notes when you're taking the mock. But to do the derivative, you take this piece and it replaces the t. And so that's their first step. But then the step that a lot of people will forget is you always multiply by the derivative of what you substituted. The derivative of 3x squared is 6x. So you have to do that. A few people forgot to do that part. So that part was not in their work, the 6x. And then they also repeated the same process for the 0. So they did minus and they plugged the 0 in, f of 0. But if you are multiplying by the derivative of what you substitute, you would need to multiply here by the derivative of 0. Go back here, we need to multiply by the derivative of the 3x squared, and then that would be correct. But because this lower limit is a 0, that's a number, when you multiply by its derivative, it knocks out that term, and so that is not necessary. So there's your first derivative. The second derivative becomes a product rule, and you can actually do the second derivative without looking back up here. So the derivative of f of 3x squared is f prime 3x squared times the derivative of the inside. Leave the second one alone. Then I left the first one alone times the derivative of the second, and you could have stopped there. I did go ahead and decide to turn 6x times 6x into a 6x squared. You don't have to do that. That actually comes into play in part C, I believe, having it simplified a little bit more. The point breakdown is you got 1 point for applying the fundamental theorem for g prime, which I think means you plugged in the 3x squared. You got 1 point for including the chain rule, which was including the 6x. You got 1 point for doing the product rule for the second derivative, and then 1 point for remembering the chain rule part in the second derivative, which is here, and then the product rule was for the fourth point. So this was a 4 out of 4 there. Moving on to part B, explain why there must be a value C such that f prime equals -1, and anytime you are guaranteeing derivative values, start with the mean value theorem, and this one was no exception. The key to the mean value theorem is before you cite or use the mean value theorem, you must say that the function is differentiable and continuous. That has to be in writing. Without that in writing, you don't get any points. Now, the points awarded were for actually writing down the difference quotient. So you had to write f of 12 minus f of 0 over 12 minus 0, or you could write this. No, I'm sorry, that actually wouldn't work. Okay, -2 minus 10 over 12 won't work because it's not a difference quotient. A difference quotient has a difference in top and bottom. So you would actually need to include the minus 0 down there. So I would say I'm going to unbox that one. You absolutely must write down the difference quotient. Do not do any of those computations in your head. And then your justification showing that that does actually equal -1. And that's where your 2 points came from, but I circled in green. However, if you don't mention that the function is differentiable and continuous, you'll lose one of those points. It's a penalty for that. So let's see, moving on to C. This was one of the more worky problems on this one. The first step should have been an automatic. You're trying to find relative minima, and anytime you're looking for that, you want to find critical numbers, and you find critical numbers by setting the derivative equal to 0. You absolutely must write down g prime equals 0. Now, if you left out this piece, if you did not include that, that's okay. If literally all you wrote was g prime equals 0, you got a point. Then you write down what your candidates are. So you got 1 point for writing down g prime is equal to 0. So there's 1 point right here. You got 1 point for identifying, what is it, for getting the critical numbers. So we had 3 critical numbers. So you got 1 point for these. So there's the other point. And then I chose to go the second derivative test. The justification in the scoring guideline I thought was really weak. All they said was that there is a minimum at 0 because G prime changes from negative to positive, which is true, but the scoring guidelines didn't have any work whatsoever to support it. Because in part A, we have the second derivative. Since we've had the second derivative, what I chose to do is I chose to plug my critical numbers into the second derivative, and all we had to do is determine if the second derivative is positive or negative. At the root 3 and negative root 3 options, we found out the second derivative is negative. If your second derivative is negative, you are concave down. Therefore, any critical number would have to be a maximum, and we're looking for minima. When I plugged in 0, G double prime ended up being positive. If the second derivative is positive, you're concave up, making your critical number a minimum. And I think that's the better option, especially since we had G double prime. And so you got 1 point for your answer with justification. So this one was a 3 out of a 3 question. Number D. This is the other part of the fundamental theorem where you're evaluating definite integrals. If they say evaluate, you are not doing Riemann sums. You actually need to find the antiderivative. And they set this one up really nicely because your u is cosine x, which is right here. There's my u. And my du is negative sine x. I had to throw the negative in there to complete it. But the negative sine x dx is my du. My u was cosine x. And I chose to convert the limits of integration. So my x's right here, my x's are values of 0 and pi over 2. So I just plugged in 0 and pi over 2 to cosine. So cosine of 0 is 1, cosine of pi over 2 is 0, and I finished the problem there. This problem, the scoring breakdown, part B here. This was 3 points. No, it wasn't. Oh, there it is. Okay, so you got 2 points for the antiderivative. So right here, that's 2 points. And then the final answer, negative 10 plus 5, or negative 5 would be the third point. And so 3 out of 3. Okay, moving on to E. And the last two are probably the worst. Showing that something is differentiable is pretty cumbersome. In order for something to be differentiable, you first have to show that the function is continuous, because if the function is not continuous, then differentiability is completely off the table. So first we have to show function's continuous, and that is done by showing that the limit as x approaches 4 is equal to h of 4. Now, if you look at the function for h, it was a piecewise function. I wish I'd written it down here. But the function for h was a piecewise function. So to do the limit, you have to consider the left and the right sides separately. So you have to do the left and the right. The left was f of 1/2 x squared minus 5. So I'll plug in 4. You get f of 3. Yeah, when you plug in 4, you get f of 3, and f of 3 is 2. The right side was negative 8x plus 34. And that also gives you value of 2. So we know the limit exists. And then you absolutely must, when you are showing continuity, you have to include the h of 4. So make sure you include that. So first thing I did is I wanted to show that the function is continuous. And then to show that the function is differentiable, what you want to do is show that the left and right sides of the derivative are the same. So I had to find h prime. And so getting an expression for h prime, you just do the derivative of the pieces. So we would chain rule f of 1/2 x squared. That gives you f prime of the inside times the derivative of 1/2 x squared, which is x. The derivative of the bottom part is just negative 8. And then we repeat the process again. We do the left side and we do the right side. And when you plug in 4 to the derivatives, you get negative 8 for both of them, and that was equal. So that is what we needed. We need the function to be continuous, and we need left and right sides of the derivative to be equal. You got, for this one, 3 points. 1 point was for considering one-sided limits. Now, I don't know if they meant one-sided limits for h or for h prime, but you get 1 point for one-sided derivatives, one-sided limits. You got 1 point for getting this derivative right here. So finding that derivative was worth a point, and then 1 point for the answer. So this one was a 3-point question. And then finally, part F for number 1, we have k defined as the antiderivative of f. they want you to evaluate this limit. Whenever I see a limit in free response that is a fraction, I will assume it's going to be L'Hopital's rule. And if you are going to apply L'Hopital's rule, you have to show that the top and the bottom both approach either 0 or infinity. You cannot do it as the limit equals infinity over infinity or limit equals 0 over 0. You have to do limit of the top equals something, limit of the bottom equals 0 something. In this case, they both approach infinity. They told you the top approached to infinity, but I still wanted to write it down. For the bottom, H was defined in part E, so I went back to part E. And if you were going towards infinity, you want large values. So we chose this piece. Plug in infinity, you get negative infinity. So L'Hopital's rule will apply. And so that means that this limit, as x approaches infinity, of k over h would equal the limit of k prime over h prime. And then to get k prime, we had to use this piece right here. K be defined as the antiderivative of f. So if you transcribe that literally, k is the antiderivative of f, but that can also be interpreted, if you differentiate both sides, that could also be differentiated as k prime of x is equal to f of x. So that's what I did here. So I replaced the k prime with f, and then as h prime goes to negative infinity, we go back to this h prime right here, h prime, as we go to negative infinity. Hold up. I'm sorry, we're going to positive infinity, my bad. Okay, so we're going to positive infinity, that is greater than 4, so negative 8 for h prime. For the f part, at the very beginning of the problem, if you look at the description of this problem, they describe f as having a horizontal asymptote at y equals negative 3. And if a function has a horizontal asymptote at y equals negative 3, that means that the limit as x goes to infinity of that function is negative 3. And so that's where I pulled the negative 3 here. And so this one, okay, you got 1 point for this top step where you showed that both limits approach negative infinity. That was 1 point. You get 1 point for applying L'Hopital's rule, so that would be right here. And then you get 1 point for your final answer, which is 3/8. And so there's your third point. And so this one was a 3-point answer. Let's look at question number 2. We have a table of values that represents the, it is P prime. Always pay attention to that. So we're looking at P prime. And it's measured in hundreds of rolls per day, representing the rate that toilet paper is being sold. Okay, so use corrected units to explain this. So we are finding the area under the rate, and the area under the rate, or the antiderivative of the derivative, will give you the total amount change. Total, there's an L, just make it really fat. Okay, so the total change. And so first, they're not asking you to explain an answer, just the meaning. So first, that definite integral will give the total change. So if this represents the rate that toilet paper is sold, this will give you the amount of toilet paper sold. So this gives the number of toilet paper rolls in hundreds. So we have to remember is that this is measured in hundreds of rolls per day. And then when you are explaining anything that has time values attached to it, you want to be sure that you include the limits of integration, or if you're explaining a derivative value, you include the point that you plugged in for the derivative. Let's see. So this one, looking at the scoring, you got, this is a 2-part. I was almost done. Okay, so you got 1 point for the explanation. There we go. Then it says to estimate this value using a left Riemann sum. Okay, when you're doing Riemann sums, or if you're doing trapezoids, if that shows up, Riemann sums are areas of rectangles, and you must show base times height for each rectangle. Even though you have a calculator and you can easily just punch this in the calculator and get the values individually, you want to write down the 4 products: base times height, base times height, base times height. They will be looking for that. And so that is your left Riemann sum. Just remember that the bases of your rectangles are the change in x. So the distance right here, so we have a change of 1, a change of 2, a change of 4, and a change of 3. And so the delta x is the base of your rectangle. And the height of your rectangle would be the left side of each interval. So from 0 to 1, we use 3.2. From 1 to 3, we use 2.4. And so the height, the function values, I'm saying f of x, I should say p prime, is your height of the rectangles. And so that's what I included here. You did not have to simplify it. You could have left it as just that product. You could have left it as 35.8, or since this is measured in hundreds of rolls, that would be 3,580 rolls. And so that was your third point on this one. You got 1 point for writing the Riemann sum, 1 point for the answer. And so 3 of 3. The second one, estimate the value of p double prime of 5. We are given the table of p prime. So if I want p double prime, I'll get rid of all this. 5 falls between 3 and 7. And so to estimate the slope, because we were looking at p prime, if I want p double prime, the slope at 5 will be approximately the slope from 3 to 7. And this goes back to kind of like the mean value theorem rules. You absolutely must write down the difference quotient. You must have a difference in the numerator and in the denominator. If you wanted to jump straight to plugging in 3 and 4.7, you could, but do not write 4 down here. You would have to actually write 7 minus 3. You have to have a quotient of 2 differences to get your point. Then you can simplify it if you choose to. It does say explain the meaning. So we found a derivative. It's technically the second derivative, but what I found is that the derivative of p prime was negative. That means that p prime is decreasing. That's my thought process, except I can't say p prime. I have to put in words what p prime is, and they described p prime as the rate that toilet paper is sold. So I had to write at time t equals 5, and this goes back to including all values. We're approximating the slope at 5, so we need to specify at time t equals 5 the rate that toilet paper is sold. That is just a wordy description of p prime is decreasing at approximately, and I'm not sure if the word approximately is needed, probably not. They're usually not that picky. And then you want to include units. So if you look on top, we subtracted p prime. P prime is measured in hundreds of rolls per day. Okay. I'm going to change that thought process because I wrote day squared here. It's kind of like an acceleration. P prime was like a velocity. It was rolls per day. So when I do another derivative, it introduces another unit of time. So it's rolls per day squared. Notice that in my answer right here, I said decreasing at approximately 1.7 over 4. I left off the negative because that negative is included in the word decreasing. If you wanted to, and if you looked at the scoring guidelines, I think they just said the rate that toilet paper is sold is changing at negative 1.7, and that would be fine also. If you use the word changing, then you do need to include the negative, but my negative is included with the word decreasing. All right, moving on. Okay, number C, explain why there must be a value that p prime is equal to 2. And I kicked into autopilot the very first time I did this. I saw that I'm trying to guarantee a derivative value. So my first thought was to start with the mean value theorem. However, this is an exception because the table I'm looking at is actually p prime. The mean value theorem would be used if we are given the original function, and we are not. So since we're given p prime, that makes this a lot easier. We can go intermediate value theorem. Just remember the intermediate value theorem hinges on continuity, so you must specify that the function is continuous. And then we are simply going to look for 2 values, any 2 values that are on each side of 2, and it just so happens that at 0 and at 10. P prime of 0 is 3.2, that's greater than 2. P prime of 10 is less than 2. Therefore, intermediate value theorem guarantees that this does happen. And you didn't have to choose those 2 points. You could have chosen actually any value from 0, 1, 3, or 7 because all of those are greater than 2. 10 is the only one that is less than 2. So as long as you picked any value greater than 2 and less than 2, that will be sufficient. And you do not have to actually name the theorem. If you left out IVT guarantees and you just said, therefore, p prime equals 2, that would be fine. I kind of like to name the theorems, but you don't have to. And then finally, the differential equation problem, they gave you a separable differential equation and they want you to solve it. So first step is to separate your variables. And I try to keep my left side as clean as possible. So I moved only the s. I divided by the s, and I multiplied by dt. And so you got 1 point for the separation. Let me go to my scoring here. So you get 1 point for separating the variables correctly. Then you got 2 points for the antiderivatives. I chose to make that 1 point for each side. The left side is easy. That's a natural log situation. So we got 1 point there. The right side, this is going to be a u sub. And over here, you can see where I did the u substitution. This is my u, 1/2 t. The derivative of 1/2 t would be 1/2. So I have my du right here. I threw in a 1/2, so I'd include a 2 on the outside. So the 1/2 dt is my du. And then the antiderivative of p prime would be p. Now, we do not have a definite integral this time, so I'm not going to be able to convert limits of integration. So 2p of u is the same thing as 2p of 1/2 t, which is the antiderivative over here. The 1/20th, I just let it come along for the ride. And so there was my second point. And then the last point, this is only a 4-pointer. The last point was getting an expression involving s and p of t. I do think you need to solve for s. What annoyed me about this one is there is no initial condition. They did not give you any values that would allow you to solve for the unknown constant. And I went back, when I finished this problem, I went back and I read the problem like 3 or 4 more times because that's so unusual. However, you were going to leave the c either in the exponent, or you could bring it down front as a different constant times a function. But there is your solving of the differential equation. That was what, 4 points out of 4? I think it was 4. Yeah, 4 points. So yeah, 1 point for separation, 2 points for antiderivatives, and then 1 point for solving for s. There we go.